everyone. So this is the presentation of Group 12. So we are going to tackle about is radio waves. So first, we are going to talk about is electromagnetism. Dictionaries defined electromagnetism as a subdivision of physics that is concerned with the study of the interacting relationship of electric currents or field and magnetic fields. So ano nga ba ang electromagnetism? It is a fundamental force of nature that describes the behavior of electrically charged particles in motion. This force is responsible for many everyday phenomena such as the attraction and repulsion of magnets, the generation of electrical currents in conductors, and the transmission of electromagnetic waves like light. Electromagnetism is described by Maxwell's equation, which formed the foundation of classical electromagnetism. Next, who is Maxwell? James Clerk Maxwell is a Scottish physicist who proposed the theory about the relation of electric currents or fields and magnetic fields. In 1873, he developed the unified theory of electromagnetism. So, sino nga ba si Maxwell? Siya ang pinakakilala dahil sa kanyang mga kontribusyon sa larangan ng electromagnetism. Ang mga equation ni Maxwell, isang set ng 4 na pangunahing equations na naglalarawan ng pag-uugali ng mga electric at magnetic fields. Ito ay pinormula niya noong 1860s. Ang mga equations na ito ay naglalaro ng mahalagang papel sa pagkakaisa ng dating magkasalungat na electric field at magnetismo sa isang solong teorya ng electromagnetism. Gumawa rin si Maxwell ng mahalagang kontribusyon sa pag-unawa sa kulay na paningin, sa kinetic theory ng mga gas at sa teorya ng init. Ang kanyang trabaho ay nagtayo ng pundasyon para sa karamihan ng modernong pisika at itinuturing na isa sa mga pinakamahalagang pag-unlad sa larangan. Next, the theory of electromagnetism. Before Maxwell pointed out the interrelationship of electric current, magnetic field, and light, it is thought that the two field and the light were one separate forces. When Maxwell studied this, he projected that the electric field, magnetic field, and light are different appearances of the same phenomenon. He further proposed 4 main interaction of electromagnetic forces. These are number 1, the force of attraction or repulsion between electric charges is inversely proportional to the square of the distance between them. Number 2, magnetic poles come in pairs that attract and repel each other, much as electric charges do. Number 3, an electric current in a wire produces a magnetic field whose direction depends on the direction of the current. Number 4, a moving electric field produces a magnetic field and vice versa. These are the explanation of the 4 main interaction of the electromagnetic forces. Number 1, it is how the force between two electric charges depends on how far apart they are. The farther apart they are, the weaker the force between them becomes. This relationship is called an inverse square law. Number 2, the magnetic poles, which also come in pairs like electric charges do. These magnetic poles can either attract or repel each other depending on their orientation. Number 3, it is that when there's an electric current flowing through a wire, it produces a magnetic field around it. The direction of this magnetic field depends on the direction of the current flowing through it. Number 4, it is how a moving electric field can produce a magnetic field and vice versa. This means that if you have an electric charge moving around in space, it will create a magnetic field around itself as well. Overall, these 4 concepts help us understand some basic principles behind electricity and magnetism and how they interact with each other. So, this is the example of the Maxwell's prediction of electromagnetic waves. Maxwell said that when such an oscillating charge is fired in the certain direction, it will carry the associated electric field and magnetic field with it, leading to the production of what we now understand as electromagnetic wave. In this wave model, the electric field and the magnetic field are changing in magnitude but always remain perpendicular and in phase. The term in phase refers to the fact that when the electric field is at maximum magnitude, so is the magnetic field. And when the electric field is zero in magnitude, so is the magnetic field. This ultimately led to the development of a new model of light, the electromagnetic transverse wave model of light.
To further understand radio waves, that follows below is a discussion and description of how Hertz produce the radio waves or pulses. The electromagnetic spectrum. It is the entire range of wavelengths or frequencies of electromagnetic radiation extending from gamma rays to the longest radio waves and including the visible light. Name of wave: radio wave. Wavelength: 1 km, 10 meter, 10 cm, 1 mm. Size comparison: buildings, humans. Frequency: 300 kHz, 30 MHz, 3 GHz, and 300 GHz. Microwave infrared. Wavelength: 10 micrometer. Size comparison: honeybee or pinpoint. Frequency: 3 times 10 to the power of 13 Hz. Visible region. Wavelength: red, orange, yellow, green, blue, indigo, and violet. Size comparison: protozoans. Ultraviolet wave. Wavelength: 0.1 micrometer. Size comparison: molecules. Frequency: 3 times 10 to the power of 15 Hz. X-ray. Wavelength: 1 nanometer and 10 to the power of negative 11 meter. Size comparison: atoms. Frequency: 3 times 10 to the power of 17 Hz and 3 times 10 to the power of 19 Hz. Gamma ray. Wavelength: 10 to the power of negative 13 meters. Size comparison: atomic nuclei. Frequency: 3 times 10 to the power of 21st Hz. Example of its radio wave. Radio wave: AM radio, amateur radio, and aircraft communication. Microwave: microwave oven. Infrared: TV remote control and night vision goggles. Visible: light or rainbow. Ultraviolet: UV light from the sun. X-ray: airport security scanner. Gamma ray: PET scan, terrestrial gamma ray flashes. Radio: your radio captures radio waves emitted by a radio station. Ringing your favorite tunes, radio waves are also emitted by stars and gases in space. Microwave: microwave radiation will cook your popcorn in just a few minutes, but it's also used by astronomers to learn about the structure of nearby galaxies. Infrared: night vision goggles pick up the infrared lights emitted by our skin and objects with heat. In space, infrared lights help us map the dust between stars. Visible: our eyes detect visible light. Fireflies, light bulbs, and stars all emit visible lights. Ultraviolet: ultraviolet radiation is emitted by the sun and are the reason skin tans and burns. Hot objects in space emit UV radiation as well. X-ray: a dentist uses X-ray to image your teeth, and airport security uses them to see through your bag. Hot gases in the universe also emit X-ray. Gamma ray: doctor uses gamma ray imaging to see inside your body. The biggest gamma ray generator of all is the universe.
What are radio waves? Radio waves are electromagnetic waves with the longest wavelength in the electromagnetic spectrum, ranging from 300 GHz to 300 kHz. They are crucial for modern technology used in cell phones, ICT communications, broadcasting, navigation, communication satellite, Wi-Fi, routers, and more. Radio waves facilitate efficient communications and signal transmissions for televisions and mobile phones. If not absorbed, radio waves bounce off objects. Ang mga radio wave ay isang uri ng electromagnetic wave na may pinakamahabang wavelength. Mahalaga ang papel nila sa modernong teknolohiya. Pinapadali ang komunikasyon sa pagitan ng mga cellphone at higit pa. Binago ang kanilang pagtuklas ang komunikasyon. Ginagawa itong mas mahusay at laganap.
So, paano nga ito produce? Heinrich Hertz confirmed the presence of radio waves in the late 1880s after being inspired by Maxwell's electromagnetism theory. In 1886, while experimenting with his devices, he observed an electrical spark that led him to further exploration and inquiry. Hertz conducted an experiment with a spark gap transmitter to test Maxwell's theory on electromagnetic waves. He used hollow spheres as capacitor at both ends of the transmitter, which stored electrical energy in an electrical field. By applying high voltage alternating current electricity across the spark gap, sparks were produced through magnetic induction between the spark gaps. Using an induction coil, Hertz converted low voltage direct current electricity into high voltage alternating current electricity, creating spark at consistent intervals. These sparks generated an aggressive pulse of electric current in the copper wires leading to the spheres, producing electromagnetic waves or radio pulses. Radio waves propagated at the speed of light through the air surrounding the wire.
Hertz was experimenting to prove Maxwell's theory of electromagnetic waves. He wanted to create a device that could transmit these waves. Number 2. The key components of his transmitter were two hollow metal spheres, each about 30 cm in diameter, placed 3 meters apart. These spheres acted as capacitors. Number 3. Hertz applied a high voltage alternating current electricity across a small gap between the spheres called the spark. This produced electrical spark across this gap. Number 4. The spark were generated using an induction coil which converted low voltage DC electricity from a battery into high voltage AC electricity. This electricity jumped across the small air gap at regular interval, creating the spark. Number 5. The spark caused rapid changes in the electric current following through the wires connected to the spheres. These rapid changes in current generated electromagnetic waves or radio waves. Hertz observed that the spark jumping across the main spark gap also caused spark to jump across a secondary gap placed nearby. This showed the waves were propagating through the air. Number 7. Further experiment related that the flexing of the main spark gap produced regular oscillating electrical waves traveling back and forth. Number 8. Hertz believed this oscillation of the circuit was key to generating the electromagnetic waves as predicted by Maxwell's theory. Number 9. According to Maxwell, the oscillating electrical circuit of the transmitter would emit electromagnetic waves with wavelength up to a meter or more in length. In summary, Hertz used his spark gap transmitter to generate and detect the electromagnetic waves that proved the validity of Maxwell's groundbreaking theoretical work. This was a major milestone in the development of radio technology.
He observed sparks moving from the main spark gap to the secondary gap. Experiments showed flickering at the main gap produced regular electrical waves. Hertz believed the circuit vibrated due to inductance and capacitance. Self-inductance in copper wires led to high-frequency electric vibration. Maxwell's theory suggested the transmitter discharged electromagnetic waves up to 1 meter. Hertz demonstrated the transmission of electromagnetic waves by observing sparks jumping from the transmitter to the receiver over a distance of 1.5 meters. 1.5 waves to receiver over a distance of 1.5 meters. These sparks were a result of the electromagnetic waves causing intense electrical vibrations in the receiver. Hertz's experiment not only confirmed Maxwell's theory but also led to the generation of the radio waves. So that is all for our presentation. Thank you for listening.